The Cloud-Assisted Real-Time Methods for Autonomy project, or CARMA, has been jointly funded by EPSRC and Jaguar Land Rover as a part of the £11 million TASCC programme. As a part of the project, researchers from the Intelligent Vehicles Research Directorate of WMG, with the support of WMG's Centre High Value Manufacturing Catapult, have been working on a proof-of-concept demonstrator. This is to highlight how the technologies and solutions developed throughout the CARMA project can support safe and efficient, highly automated driving on complex road segments.
We expect autonomous vehicles to be much safer, much more efficient, and much more comfortable than human-driven vehicles. Unfortunately, with existing sensor technologies and computing technologies, it is difficult and expensive to achieve the level of accuracy and reliability of the perception of the environment that's expected. Therefore, we develop cutting-edge technologies and techniques that will help autonomous vehicles to obtain highly accurate and highly reliable perception of the environment.
For complex road junctions, the CARMA platform can help support on-road autonomy. So the ability to do sensing, but also processing on vehicle, as well as on the edge, and then also on the cloud as well. And the fact that the platform is modular, you can add additional nodes, for example, vehicles or edge nodes, and be able to collect more information about the environment to then be able to distribute and share and make use of that information.
The CARMA platform can be used to improve various aspects of automated driving systems, such as in this case, safety and efficiency. We've tried to demonstrate this using two separate use cases, each with one vehicle connected to the infrastructure.
The smart road infrastructure at the connected roundabout comprises 8 CCTV cameras that monitor the environment and stream video to a base station called EDGE via millimetre wave communication. This EDGE processes and transmits live information about objects, traffic and road layout, including lane availability, periodically to any connected vehicles. The lane information includes the structure of the road, along with the availability of the lanes due to traffic. Both EGO vehicles check their onboard camera and LiDAR sensors for nearby objects. Each vehicle produces a local object list using fused camera and LiDAR data. This list contains the information on the surrounding objects. This includes the type of object, such as a pedestrian or vehicle, as well as their location. The EDGE also generates its own local object list via the CCTV cameras. The EGO vehicles transmit their local object lists as a collective perception message, CPM, to the EDGE infrastructure via ITS-G5. All local object lists are combined at the EDGE to create a global object list which is broadcasted. The EDGE also broadcasts two other types of messages, named MAP and Signal Phase and Timing, SPAT, periodically to all nearby connected intelligent vehicles. The MAP message provides lane and location information for the surrounding road area. The SPAT message conveys the status of lanes in the road area. The EGO vehicles involved in the demonstrations receive all three messages as they approach the roundabout. Each vehicle uses these messages to understand which lanes, if any, are available.
In use case 1, the EGO vehicle approaches the roundabout and is intending to take the third exit. However, the EGO vehicle learns there's congestion on the exit, so instead it takes another exit to avoid this congestion. This demonstrates the capability of the CARMA platform to avoid traffic jams.
The EDGE detects congestion on an exit of the roundabout using object detection and localization and sends a SPAT message with this information. Once the EGO vehicle receives this SPAT message, it identifies that there is an unavailable lane on its planned route and changes to an alternative. The vehicle now approaches the roundabout entry in a different lane.
In use case 2, demonstrating the safety aspect, the EGO vehicle approaches the roundabout with a van along its side. The van blocks its view, so you're not able to see the roundabout clearly. But using the infrastructure's information, it will be able to see the surrounding and make safe decisions into roundabout. This demonstrates the CARMA platform ability.
Whilst at the roundabout, the Ego vehicle uses the global object list to look for vehicles outside its view. With this information, the vehicle makes a decision of safe entry into the roundabout and continues on its planned route. With the use of the cloud, information from edges located on other junctions can be relayed to connected vehicles further away. This allows for a reroute of the planned journey much earlier. The future thus could see a connected intelligent vehicle receiving more information from further afield, allowing it to better plan a route before the journey even begins. There are many possibilities for cloud-assisted real-time methods for autonomy.
We have not only demonstrated how these concepts could be implemented in practice, we have carried out intensive research on how these could be used and what will be the impact. And the work in this research will help the manufacturers, technology developers, policymakers, and road operators to make informed decisions on how they will adopt technologies in the future, road infrastructures, regulations, products, and services.
The main beneficiary of this new technology is our public. This technology brings the new business models for the transportation system, as for example, the ride sharing or mobility as service. The second one is that our elderly people or maybe disabled people can benefit the joy of driving from point A to point B. The third is a safer and cleaner transportation system.
Autonomous vehicle technology is a story in progress, and still we need to address many technical, regulatory and business challenges before we can deploy the technology en masse. And the benefit in long term for the public will be in terms of increasing safety of the roads, efficiency of the transport systems, and reducing the cost of the technologies for the consumers.